been classified into S, P, D and F block elements, right? How do they classify S, P, D, F block elements? On the basis of the number of electrons in the outermost shell. Suppose if we are talking about the S block elements, that means the last electron enters the S orbital. How many electron S orbital can occupy? 2. So what are the possibilities for the elements? S1 configuration or S2 configuration. Then on the basis of S1 and S2 configuration in the outermost shell, the S block elements are further divided into alkali metals and alkaline earth metals. What is the difference between alkali and alkaline earth metals? Anyone? Alkali means it is derived from the word alkis, that means ashes of plants. Ashes of plants contain carbonates of sodium and potassium. That is why these S block elements having the elements lithium, sodium, potassium, next rubidium, cesium and francium, right? These are called alkali metals, while the alkaline earth metal composes, anyone? Beryllium, then magnesium, calcium, strontium and barium, right? These have the outermost electron configuration of Ns2. N is the principal quantum number that we do not have to consider in this case, okay? So first we will discuss the alkali metals, right? Since the outermost electronic configuration is Ns1, this is the general electronic configuration in the outermost shell. So first of all, we have to decide its physical properties as well as chemical properties. Physical properties are decided by which factors? Physical properties. Yes? Melting point. What are the physical parameters? Melting point, boiling point and atomic size or ionic size, right? Can it lose one electron or two electrons? One. After losing one electron, it will attain a noble gas configuration. That means if this is n-1, 6 p6 s1, after losing one electron, it will become n-1 6, right? It will attain a noble gas configuration, which is difficult to break, right? Then among the physical property, first of all we will discuss the atomic sizes. We know that this is across the period train and this is down the group period train. So we are considering alkali metals. So down the group, what do you think? The atomic size will increase or decrease? Increase due to increase in number of shells. Each time an additional shell is increasing, right? What is the atomic number for lithium? 3. Next, sodium के लिए it is 11. What is the electronic configuration? 1s2, 2s1. This is 1s2, 2s2, 2p6, 3s1. Each time then this is potassium. This is 19. Again this is 4s1, 5s1 and this is 6s1, right? On going down the group, the atomic sizes increases due to addition of an extra shell each time, okay? Then after losing one electron, does the size train changes? Do you think that when the atomic size, this is atom, we are talking about atoms, when it has not lost any electron. So if I am talking about an ion, after an atom has lost its electron, if I am talking about ion, so do you think the trend will change of the atomic or ionic size? No, because the number of shells are intact. They are not changing. Only this last electron has been lost, right? The next property is, so this is atomic size. Down the group, atomic size has increased, right? The other properties is Melting point and boiling point. So what should be the trend for melting point and boiling point? Down the group it should increase or decrease? Increase, are you sure? Why so? No, because the attraction between the nucleus and the electrons is decreasing. That is why the melting point and boiling point will decrease down the group. Okay, clear? Then other property is density. What is density? Density is mass over volume. So if I am saying that down the group the density decreases, what does it imply? It means either the mass is increasing or the volume, either the volume is increasing or mass is decreasing. So what do you think if I am saying that down the group the density decreases? That means volume increases. That means because each time an additional shell is being added to the atom. That is why the density decreases down the group. Next property is electropositivity. What is electropositivity or electropositive character? Electropositive character, that means it can lose electron. What is electronegativity? That means it can accept electron. What is electropositive character? It can lose electron. So down the group, what do you think? The electropositive character should increase or decrease? Sorry? Increase or decrease? Increase, because again down the group the number of shells are increasing and the attraction to this nucleus, to this electron is decreasing, and hence this electron can easily take its way out of the atom, right? It can easily lose the electron na? Because it has reduced attraction to this nucleus. जितना ये इलेक्ट्रॉन न्यूक्लियस के पास होगा उतना ही इलेक्ट्रॉन निकालना मुश्किल होगा. Therefore, इसको इलेक्ट्रॉन निकालना is difficult. Rather, this rubidium and cesium. ठीक है? So down the group, the electropositive character increases. The other property is flame colors. What are flame colors? Flame colors. Has anybody heard of it? If I take any element, say like lithium or sodium or potassium, if I put this on a platinum wire and heat it on a flame, then it will produce some color. Why so? Why some elements show color on burning? Because of electron volt. Because these electrons are excited to higher energy levels. What does flame do? Flame provides extra energy to the electron. Okay, flame is a type of energy. Flame provides energy to this electron. In turn, this electron gets excited to higher energy level, and this, while returning to its original place, this emits energy in the form of the visible light. Each metal has its own characteristic color. Okay, any idea what does? Have you heard about sodium lamp? What color it has? Green, blue? It's yellow. Sodium lamp is yellow in color. So why it's yellow? Because when heat is provided to the sodium metal, the electron from the outermost shell get excited to another higher state level, and while returning to its original shell, it releases visible light. Okay, that is why it appears color. Okay, next property is ionization energy. Down the group, ionization energy should. What is ionization energy? This is the energy required to remove the most loosely bound electron, right? If this is the configuration for my atom 1s2 2s1, then the ionization energy is something like say 298 kilojoules per mole. So that means this much energy is required to remove this electron from this outermost shell. This is the ionization energy required. If I want you to go out of the home, so I should give you some energy, na, that yeah, this is a place to hang out with and you should go out, right? So this is sort of ionization energy to take you out of the shell. Okay? So down the group, the ionization energy should increase or decrease? Decrease, because again the attraction to the nucleus is decreasing with each progressive shell, and hence the ionization energy will decrease down the group. You have to make sure that you know the trend down the group and across the period. Since we are talking about only alkali metals right now and it is only down the group, it's okay that you have to know the trend down the group for each physical property. This is all physical properties. What are chemical properties? Chemical properties owe their characteristic due to what? Due to some electrons exchange or what? Anyone? Can alkali metals react with water? What is chemical properties? Chemical properties, that means it can react, it can chemical activities, chemical reaction, right? These are the chemical reactions of alkali metals. So do you think alkali metals can react with water? All of you have performed experiment in the lab for the sodium metal. Have you? So have you noticed that the sodium metal was kept under some liquid in the china dish? What was that? Kerosene. Why so? Why not water? Why it reacts with water? How it reacts with water? So if I am saying this Na is stored under kerosene and not with water, because the sodium metal will react with water to form hydrogen gas, which will catch fire, and hence alkali metals are always stored under kerosene or some other non-reactive liquid so that it does not catch fire. Other product would be 2NaOH, right? If I am saying that this is, so other liquid could be kerosene, or can it be stored under alcohol? Why not? Alcohol is C2H5OH, right? Can't I store it under any ethyl alcohol? Why? Again, it will go a reaction to form hydrogen and C2H5 Na, ONA, right? This is a combustible gas. It will catch fire immediately because its ignition temperature. What is ignition temperature? Ignition temperature is the temperature at which a substance catches fire. So its ignition temperature is very low, and hence these alkali metals are stored under kerosene or some other non-reactive liquid so that they does not catch fire. Okay, so next time keep in mind that while using sodium metal in the lab, do not put the sodium pieces outside the china dish. Okay. Next is reaction with oxygen. Can alkali metal react with oxygen? Kaise? So suppose if I am saying this is the metal, this is the first metal of alkali metal. This is lithium, sodium, potassium, right? If I am saying does they react with oxygen? What do you think? What will be the product? Huh? This would be Li2O, this would be Na2O2, this would be KO2. What is the difference between these oxides? So we are very much aware that after reacting with oxygen, any metal would form oxide. But this is lithium oxide, but this is sodium peroxide, and this is potassium superoxide. What is the difference between oxide and peroxide and superoxide? Just oxidation state. Oxide is O2 minus, single oxygen atom having 2 unpaired electrons. So peroxide is O2 2 minus. Here we have 2 oxygen atoms having two electrons. Then Superoxide is O2 minus, having only one unpaired electron. So this should be what? This should be paramagnetic or diamagnetic? What are paramagnetic and diamagnetic? Paramagnetic species is the one having only one unpaired electron, while diamagnetic is the species having paired electron. What is the electronic configuration? What are the number of electron in this superoxide? Please make sure you write. This is superoxide, this is peroxide, and this is oxide. Right? Now tell me, what are the number of electrons in superoxide? This is 17. So according to molecular orbital diagram, should be the electronic configuration? 1s2, 1s2 star, right? 2s2, 2s2 star, then 2pz square, 2px square, 2py square. How many electrons till now? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Still 3 to be filled. Then it would be 2p y or x, 2px star, 2, and 2p y star, 1. And hence we have one unpaired electron. And hence this is why this is paramagnetic. Paramagnetic compounds are colorful or colorless? And why they are colorful or colorless? Because whenever there is any free electron, it is free to move outside the shell and get excited to another higher level state. Anything cannot stay in the higher state. Now, if I start jumping, is it possible that I can stay in the air? I'll go to my original state, minimum energy state, right? So, if this electron, after absorbing some energy, some sort of energy in terms of flames or anything, if it gets excited to another level, another higher level, will it stay there or it will revert back to its original state? It will revert back to its original state. Therefore, after absorbing energy, when it will revert back to its original state, it will emit some energy in the form of light. That is why we observe different colors for different alkali metals and alkaline earth metals as well. Got it? This is the unpaired electron for paramagnetic. This is peroxide. What are the number of electrons in O2 2 minus? 18. So electronic configuration would go as same in the only difference would be 2pz square, 2px square, 2py square, 2px square, 2py square. That means this last electron which was unpaired in the superoxide will be paired in this peroxide moiety, and hence this species would be diamagnetic, and hence its compounds would be colorless, okay, and these would be colorful. And what about oxide? What about oxide? It would be paramagnetic, are you sure? Number of electrons in O2 2 minus 10, 1s2, 2s2. It will comply with the atomic orbital diagram. This is not a molecule, these are molecule O2. This is again only an atom. This is the difference, make sure. MOT is molecular orbital theory, is applied to molecules, but this is O2 2 minus is an atom, and hence its electronic configuration would go 1s2, 2s2, 2p6. Hence there is no unpaired electron, it is diamagnetic. Okay, so what were we discussing? That why lithium forms an oxide and why sodium forms a peroxide and potassium forms a superoxide. Because down the group, lithium, sodium, potassium, the size increases. This is the combination Li2O, Na2O2 and KO2. Each time the size of the atom is increasing, and also the size of this counter ion. Counter ion means opposite ion. If this is cation, this is an ion. The size of counter ion, an ion, is also increasing. A small thing would prefer a big thing to bound, or a small thing would prefer a small thing to bound? small. A small thing would always prefer a small thing to bond, and a bigger thing will prefer a bigger thing. This is called Pearson principle. Okay, so since lithium is the smallest element in the alkali metal, it would prefer a smaller atom, smaller counter ion. Similarly, Na sodium is a medium size atom, it would prefer a peroxide ion. Similarly, potassium is a way bigger ion than sodium, and hence it will prefer a more bigger ion, that is superoxide. Okay, peroxide was smaller than the superoxide. The order of the sizes, oxide is smaller than the peroxide, then the superoxide. This is the order. And hence, to comply with the Pearson principle that a big thing would prefer a big thing and a smaller ion would prefer a smaller ion, there is a difference in the oxides form. This is lithium oxide, this is Li2O, then Na2O2, that is sodium peroxide, and then this is potassium superoxide. Getting the difference? Is there any doubt? All clear? Okay. Next is, so far we have done reaction with oxygen and water. The other reaction could be with nitrogen. Air contains oxygen and nitrogen basically. What is the percentage of nitrogen in the air? Good. Nitrogen is 70% and oxygen is around 21%, I guess. So, while considering the reaction with air, we have considered reaction with oxygen. Now we will consider reaction with nitrogen as well. So, if I am saying lithium is combining with nitrogen to form lithium nitrite. This is the formula because nitrogen has a valency of 3 minus, right? And hence it will form lithium nitrite. Sodium would form sodium azide. Azide is again N3 minus. Okay, this would be Na3N, right? Then potassium would form. Does potassium react with nitrogen? Does it? No, it does not react with nitrogen, and hence this reaction is nullified. Okay. Nitrogen is reactive up to only 2 elements of the alkali metals. Next reaction could be with hydroxides. What is the difference between base and an alkali? I am sure you must be knowing both the terms base and alkali. Base is something which dissolves in water to give OH minus ions. A base which dissolves in water to give OH minus ion is called alkali. Base could be either hydroxide ions or carbonate or bicarbonate, but it is not necessarily that it should give OH minus ions. This is a basic solution. Okay, and when a base dissolves in water to give only OH minus ions, it is called alkali. This is the difference. These small difference you should know. Okay, what are hydroxide? Having OH minus ion. So if this is OH minus ion, alkali metals can react with water to form hydroxide. This is an alkali metal, it will react with water to form hydroxide, having the formula MOH plus what? H2. So if I am saying lithium is reacting with water to give lithium hydroxide, similarly sodium is reacting with water to give, what is the other name of sodium hydroxide? Caustic soda. Soda is derived from the sodium, and caustic means it destroys anything which it touches. Okay, that is, it has very destroying properties. that we can say. Okay, the other is potassium plus water gives KOH. Other name is caustic. Caustic what? What should be the name? Caustic potash. Okay, potash means potassium. This is the reaction with water. So far we have done reaction with oxygen, nitrogen and water. And anything? Sorry? Clear? What are the main? Can alkali metals react with hydrogen as well? What if I react a metal, alkali metal with hydrogen? Can it react? Have you heard about metal hydrides? What are hydrides? This is hydride. Okay? This is when hydrogen combines with metal. Hydrogen is combining in the minus form, that is it is acting as an anion. It is called metal hydride. So lithium can form hydride with hydrogen to form lithium hydride. Again sodium would react with hydrogen to form sodium hydride. It would be Na 2NaH, right? Then potassium, similarly this would be 2KH, right? What are the applications of hydride? I'm sure you must have studied in organic chemistry some reagent like LiAlH4 or NaBH4. कहाँ से आता है वो? These are what? These are hydrides only. This is the hydride of aluminium and this is the hydride of boron. Okay? So what are the applications of hydride? They act as reducing agent. So hydrides have the application of reducing agent. Right? Other next example. What are the commercial products, commercial importance of these products? NaOH, or all of you use washing powder. It contains washing soda. What is the chemical composition of washing soda? You must have studied in 10th class, right? This is sodium carbonate 10H2O. This is sodium carbonate. This is washing soda. Any other compound of commercial importance of this group? Baking soda. What is the formula? Baking soda or baking powder? There is a difference between baking soda and baking powder. It is baking powder. This would be sodium hydrogen carbonate. Okay, next is any other example, any commercial compound. Sorry, NaCl. Of course, NaCl. What is the application of NaCl except from a taster, except from a sprinkler in your house? It acts as a disinfectant. Okay, it acts as a disinfectant. This is also called, NaCl solution is also called brine solution. Okay. So what are the applications of these compounds? Any other application of these compounds or any other compound of this group, alkali metal? Yes? The other is okay, let's take it. These three are the main important compounds which could be asked in the MCQs of the entrance exams. Next is, if I'm talking about the solubility. So how does solubility varies down the group? Solubility means a compound should dissociate into its constituent ions. If I am saying NaCl is getting dissolved in water, that means NaCl is dissociating into Na plus and Cl minus ions, right? So how does it work? To get dissolved this NaCl, the NaCl crystal should break down. And how would it break down? Solvation energy, right? More precisely, you say it hydration enthalpy. Hydration enthalpy. What is the factor that is keeping Na plus and Cl minus intact together? Lattice energy. All of you have heard about lattice energy? Lattice energy is the energy released when cation and anion combine together to form a crystal. Okay? So if I want this crystal to break down into its constituent ions, in this case, this hydration energy should, hydration enthalpy, or we can say enthalpy, should exceed the lattice energy. That means hydration enthalpy should be such that it would be able to break the lattice energy factor. Getting the point? If the lattice energy is smaller than the hydration energy, then the ions would prefer to get dissociated in the water. If they are getting more favorable into the solution phase, then would they prefer a lattice form? Therefore, when the hydration enthalpy is greater than the lattice energy, we say that the compound is soluble. So whenever someone asks whether the compound is soluble or not, just look at the lattice energy values and the hydration enthalpy values. If this is greater than the lattice energy, that means the compound is soluble, and if this lattice energy is greater than the hydration energy, that means the compound is insoluble. Down the group, what should be the trend of the solubility? Down the group, what is the trend of lattice energy? Decrease, sure. Down the group, lattice energy should increase or decrease? Decrease? I am getting mixed answers. Decrease or increase? Decrease. Okay? So if lattice energy is decreasing, that means hydration energy would increase. What is the hydration energy? Hydration energy means this Na plus ion. Suppose if I am taking Na plus ion, sodium ion, it would be covered by, it would be surrounded by H2O molecules. Okay? So you think is a smaller ion is easy to hydrate or a bigger ion is easy to hydrate? Smaller ion is easy to hydrate. So if I am comparing lithium, sodium and potassium and cesium as well, lithium, sodium, potassium and cesium and rubidium, what is the ionic size? What is the order of ionic size? This is the smallest, right? So you think the smallest ion is easy to approach for the water molecules. This is a smaller ion. Suppose this is an ion. All the water molecule can easily approach it as compared to a bigger ion. Bigger ion will able to compensate only smaller water molecules in comparison to smaller ion. If this is a smaller ion, more and more of water molecules can come to it. That means its hydration shell. This is called hydration shell. This would be bigger for smaller ion. That means if the hydration shell, that is hydration energy of smaller ion is greater than the bigger ion, that means this ion would be more soluble than the bigger ion. So the order of solubility would be lithium is more soluble than, lithium ion would be more soluble than sodium, then potassium, then cesium and then rubidium. Okay? If this is the trend for the size, this is the trend for the solubility. Getting? Next application is solutions of metals in ammonia. Has anybody studied about it? metals of solution. If I take a metal and dissolve it in the ammonia solution, all of you know about the ammonia solution, right? Has everybody used ammonia in the lab? No or yes? You have not used ammonia in the lab. Okay, no problem. Metals may dissolve in the ammonia solution. Ammonia is basic or acidic? Basic, right? This is a basic solution. Metals can dissolve in ammonia solution to form metal ammoniates. If this is metal plus X plus Y, I am saying that some moles of NH3, some mole of ammonia are involved in this process, then it will form X amount of M plus Y amount of NH3 electrons. This is a combined form actually. These form blue color solutions. So if I know that the solution contains ammonia and if it is blue in color, I can say this is the solution of ammonia ion with metal ion, with alkali metal ion or alkaline earth metal ion. Both alkali and alkaline earth metal ions show this property. They both dissolve in ammonia to give deep blue color solutions. And if I concentrate the ammonia solution, if I take more amount of ammonia, then this color of the solution would change into bronze color. Okay, this is the application. Bronze color will be due to formation of metal amide. So deep blue color of solution is due to metal ammoniates and bronze color is due to metal amides. So if I am saying that the sodium metal is getting dissolved in ammonia, it would form sodium amide and it would be bronze colored solution. Okay, and if I am saying it is a deep blue color solution, that means the ammonia solution is diluted. Okay, getting the difference? Can alkali metals react with carbon? To form, they can react with carbon to form carbides, right? Carbides are, suppose lithium is combining with carbon to form lithium carbide. Similarly, sodium would combine with, will sodium and potassium would combine with carbon? Would they? No, they will not combine with carbon to form carbide. Only this form, lithium, can combine with carbon to form carbide, because this carbide is a smaller entity similar to the lithium ion, and hence their bonding would go gel. Okay. Next we have alkaline earth metals. Any doubts till alkali metals? All clear? Okay. Alkaline earth metals. Why they are called alkaline earth metals? Because they are found in the earth crust. Major amount of is found in the earth crust. Okay. What are the elements in the alkaline earth metals? Beryllium, then magnesium, then calcium, then strontium and barium. What is the atomic number for beryllium is 4, then 12, 20, then 30, 38, then 56 or 57, 56, right? Electronic configuration would be 1s2, 2s2, 2s2. This would be 1s2, 2s2, 2p6, 3s2. Then similarly 4s2, 5s2 and then 6s2. we can see from the electronic configuration that it can lose either one electron or two electrons. Can it lose more than two electrons? It can, but it will require a large amount of energy to disturb this shell. Moreover, this shell, this 1s2, is closest to nucleus. This is nucleus, this is 1s shell, and hence its attraction to the nucleus is very high, and hence we can take out this electron, but it will require a very large amount of energy, and hence it is not favorable to take out this electron. It can maximum take out 2 electrons from the outermost shell. Similarly, it can take out 2 electrons. So if I am taking out the electron, I will talk about the ionization energy. Ionization energy, if I am saying that this is 1s2, 2s2 for beryllium. If I want to remove this electron, 1s2, 2s1, I want this configuration. I'll remove just one electron. There would be some ionization energy. I'm writing this ionization energy as ionization energy 1. In the another step, I would take out another electron to make it 1s2, 2s0. This would be ionization energy 2. So what do you think? Which ionization energy is greater? 1 or 2? Ionization energy 2 would be greater than ionization energy 1. Why so? Because it is easier to take out this one electron. But once it has lost one electron, it will become a charged species. Charged species implies that this is the nucleus and this is the electron in 1s2 and this is the electron in 2s1. After taking out one electron, this is 2s1. That means there would be number of electrons would be 3, and here the number of protons are 4. So the effective attraction is greater. That means nucleus has more positive charge. So would it allow the another electron to lose easily? No, because previously there was number of protons were equal to number of electrons, but now the number of protons are exceeding the number of electrons, and hence nucleus would not allow easily to take out another electron, and hence ionization energy 2 would be greater than ionization energy 1. Okay? So this was the ionization energy. So what should be the trend for ionization energy down the group? Decrease. Sure? Why so? Because each time a shell is increasing and hence the attraction from the nucleus is decreasing. Right? The attraction from this nucleus is decreasing with the distance, with the increasing number of shells. Next properties. On the similar lines we have discussed for alkali metals, we will discuss the properties for alkaline earth metals. The first property was physical properties we were discussing. First property was atomic size, atomic, and we will talk about both atomic and ionic size. Ionic size or ionic radii. Okay? So down the group, atomic radii should increase again because addition of extra shell, right? The other property is melting point and boiling point. Again, it should again decrease down the group, right? Third is density. Density should increase or decrease? Should decrease down the group. Then other property was electropositive character. So when we discuss about the electropositive character, that means losing a electron. So we have to talk about both the ionization energy. In case of alkali metals, there was only one ionization energy because there was only one electron which the atom can easily lose. In case of alkaline earth metals, there are 2 electrons which it can easily lose, and hence while talking about the electropositive character, I have to consider both ionization energy 1 and 2, and I have to make sure that I have accounted for both the ionization energy. Okay, then again the electropositive character down the group would increase. Then next property was flame colors, right? Flame colors means when any alkali metal or alkaline earth metals are put to flame, they impart colors to the flame. That means their electron get excited to the higher energy level, and while returning back to its original state, it will emit some energy in the form of light, in the form of colored light, okay, which we call as visible region. All of you are aware about the UV region, visible and infrared region, right? In the physics you have studied about electromagnetic spectrum, right? When this electron reverts back to its original state, it releases energy in the visible region, and hence we can see colors only in the visible range. No? Can we see in the UV range? Can we see the UV rays coming from the sun? No, no. And hence we observe colors only when the energy emitted is in the region of visible region, right? Any other physical property? Ionization energy we have sort of discussed in the electropositive character. Okay, ionization energy second would be always greater than the ionization energy 1. Okay. Now the chemical properties. What was the first chemical property? Reaction with the oxygen. Okay. So first element is beryllium, the other is magnesium and then calcium. Beryllium will combine with oxygen to form beryllium oxide. Simple. Then similarly magnesium would combine with oxygen to form magnesium oxide, right? Similarly calcium would form calcium oxide. What is calcium oxide? Other name for calcium oxide? Quicklime or slaked lime? This is also called quicklime. Okay. This quicklime can combine with water to form calcium hydroxide. This is called slaked lime. These are very important terms from the examination point of view. Slaked lime. This is also called, this reaction when we are converting quicklime into slaked lime, this is also called slaking of lime process. Any other way of preparing calcium oxide except from this reaction? Decomposition of calcium carbonate. Has anybody seen calcium carbonate? Where? Chalk. Chalk is calcium carbonate. Calcium carbonate, if we heat it, calcium carbonate, it will form calcium oxide and it will release carbon dioxide. Right? All of you have heard about the reaction called if we pass carbon dioxide through lime water, it will turn milky. What is lime water? Slaked lime, that is slaked. Slaked lime, if I pass CO2 through lime water is only slaked lime. It will turn milky, that means it will form calcium carbonate plus H2O, right? And there is another extension to this reaction. If I pass more of carbon dioxide to this reaction, that means CaCO3 plus CO2. If I pass more of carbon dioxide to this solution, the lime water, which was milky, will again turn into transparent solution. Why? Due to the formation of calcium hydrogen carbonate. Calcium hydrogen carbonate, this is also called bicarbonate, right? Everybody is known, na? This is carbonate and this is bicarbonate. Okay. What is the reason for temporary and permanent hardness of water? It is due to presence of how do we classify water in terms of hardness? It is either temporary or permanent. Permanent hardness is when the water contains sulfates or carbonates. Sulfates or carbonates or chlorides? Chlorides. chlorides and sulfates of calcium and magnesium. When the water contains sulfates and chlorides of calcium and magnesium, we classify that water as having permanent hardness. And when the water contains bicarbonates of calcium and magnesium, we call that the water has some temporary hardness. So you think that temporary hardness can be removed or permanent hardness can be removed? Which is more easy? How do we remove temporary hardness? Sorry, you're not audible. How can we remove temporary hardness? We can remove temporary hardness by heating. This contains this amount, this compound, water contains this compound. In temporary hardness, if I heat it, heat is denoted by this triangle. Okay? If I heat it, then the carbon dioxide will go out and I'll be left with calcium carbonate, which will precipitate out, जो नीचे settle हो जाएगा, ठीक है, after heating. ठीक है? This is how I remove temporary hardness of water. And if I want to remove the permanent hardness of water, so what should I do? I should remove these ions, sulfates and chlorides. So how should I remove these sulfates and chlorides? I should replace these ions by some better ions which do not cause hardness of water. So what should be according to you, what should be the ions? Can I replace it with carbonate? And then I can precipitate out that carbonate. So if I treat it with, if this is the water having calcium sulfate, if I treat it with slaked lime or calcium, it will form calcium carbonate, which I can take out. It will precipitate out as calcium carbonate, and hence the permanent hardness of water is also removed. Clear? So this was the reaction with oxygen. Other reaction would be with okay. This is the question, how does the density will decrease down the group? Density. What is density? Density is mass over volume. So if I am saying that down the group the density is decreasing, that means either the volume is decreasing or volume is increasing or mass is decreasing. Since mass is not, I am not taking mass here. Since I know that the volume is increasing. How does volume is increasing? Because each time an extra shell is being added to the atom. That means if initially this was volume, after down the group having number of elements, when the atomic number has increased, the number of shells has increased. That means the volume has increased. And this way I can say that down the group, due to increase in volume, the density has decreased. Clear? Next property. Reaction with, earlier we did with alkali metals, right? So reaction with nitrogen, right? If this is the compound, if this is the atom, beryllium plus nitrogen, what would be the product? Magnesium and calcium, right? Basically these initial three or four elements are the elements of commercial importance, and hence we are studying only these reactions. You must be thinking, no, we are not considering cesium and strontium and barium, right? Because these three elements are the elements of commercial importance, right? So what would be the reaction of beryllium with nitrogen? It would form a nitride, right? What would be the formula for nitride? B3N. Are you sure? B3N2. This is because nitrogen has a valency of -3 and beryllium has a valency of +2. So it would be B3N2. Make sure you balance the equations. Okay. Next is magnesium nitride. It would be Mg3N2. Magnesium nitride. Similarly, this would be calcium nitride. Clear? Other reaction would be with water, right? Alkaline earth metals can combine with water and form hydroxides. MOH. These are hydroxides, right? So if I am saying beryllium is combining with water to form beryllium hydroxide, then magnesium to form magnesium hydroxide, similarly calcium hydroxide, which is also called slaked lime, right? Does anybody know this concept, diagonal relationship? What is diagonal relationship? Sorry, this is BE3, sorry, it would be BE3N2. Sorry, I mistakenly have written B3N2. This would be boron nitride. Okay, this is beryllium nitride. What is diagonal relationship? Everybody know that this is the periodic table: lithium, beryllium, magnesium, calcium, rubidium, strontium, cesium, barium, and this is which group element? First, second, then we have 3, 4, 5, 6, 7, 8, 9. This is, in between we have which group elements? D block elements, which includes scandium, titanium, vanadium, cobalt, iron, nickel, copper and zinc. Then again we have 13th group element. This is called boron. So this is boron having the B, C, 14, 15, N and 16, O group element. This is called P block elements. What is the element after boron? Aluminium, then gallium, then indium and then thallium, then silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, sulfur, selenium, tellurium and polonium. Right? Everybody knows this. We are talking about alkaline earth metals. I was asking what is diagonal relationship. Diagonal relationship is when this lithium and this magnesium having the diagonal relationship, having the same properties. Why they have the same property? How does it matter if they do not lie on the diagonal or not? Because when they lie on the diagonal, they have same atomic size and almost same charge to radius ratio. Why it is so that in the diagonal relationship they have these two parameters same? Because down the group the atomic size increase while across the period it decreases, and hence if I'm going by diagonal, it would balance out the things, right? If in this direction it is increasing, this is decreasing. If I go midway, it would be balanced, and hence lithium and magnesium would have same properties, having the same atomic size and having the same charge to radius ratio. Getting? Similarly, beryllium has the diagonal relationship with aluminium. This is the way. Okay, so we have basically two relationships to study in the diagonal relationship, lithium and magnesium, and then beryllium and aluminium. Okay, so if I am talking about any lithium property, then magnesium would also possess the same property due to the same atomic size and the same charge to radius ratio. Similarly, beryllium has the same properties as that of aluminium. Right? This is what diagonal relationship is. So if I want to discuss beryllium, does everybody knows that each first element of the periodic table or the any block elements, say like lithium and beryllium, show anomalous behavior. What is anomalous? That means weird behavior, different from the other elements of that group. So if I am saying lithium, sodium, potassium, cesium, right? This lithium would behave differently as compared to other elements of its group. Similarly, beryllium would behave differently as compared to other elements of its group. Why so? Because this element has exceptionally small size and small electronegativity or electropositivity because they are closer to nucleus. Small size covers this factor, right? This is the reason why first element of each group behaves anomalously, right? So what is the difference in behavior of beryllium and other p block elements? Any difference you know? Beryllium, any compound formation? No? So far we have talked about the oxides, right? Oxides are formed when the metal ion combines with oxygen. Hydroxides are formed when they combine with water, right? And other reaction was with nitrogen. They form nitrides, M3N2, right? Other reaction could be with, please have a look at the alkali metals before. What was the other reaction? With the hydrogen. So metal can react with hydrogen, alkaline earth metal, to form MH2, because this is a divalent metal ion while hydride is only univalent. So to balance the valency, I have to make sure this is MH2. Any example of MH2, any hydride of alkaline earth metal? If I am saying beryllium is reacting with hydrogen to give beryllium hydride, right? Then magnesium would react with hydrogen to form magnesium hydride. Similarly, calcium hydride, right? But basically the application of hydrides lies in their property to act as, what are the hydrides made for? Act as reducing agent, right? Next property. What are the compounds of commercial importance? Commercial importance compounds of S block elements of alkaline earth metals. First was calcium carbonate, right? What is calcium carbonate? You have chromium and manganese. Chromium and manganese. What does it mean? Okay. So the answer was scandium, titanium, vanadium, then chromium, manganese, iron, cobalt, nickel, zinc, copper. 29, right? This is 29, 30, 28, right? So what are the compounds of commercial importance? Calcium carbonate, calcium oxide quicklime, calcium hydroxide slag lime. This is barium hydroxide. What is the name for barium hydroxide? Baryta water. Again, this is a question important from MCQ's point of view. This is the technical name. This is the common name from Baryta water. Barium hydroxide solution. All of you know the application of calcium hydroxide, calcium oxide. These are used in the manufacturing of cement and any other application in the building materials, right? In the cement and any other application of calcium carbonate and calcium oxide. Purification of sugar. No, for that we use activated charcoal. What is activated charcoal? Charcoal is obtained from coal. Coal is form of carbon only. So charcoal is basically, when we say, you have seen the advertisement that this toothpaste, this face wash contains charcoal. What does charcoal do? Charcoal absorbs the impurities on the surface. Okay, just like a chalk. If I'm taking a chalk, if I dip that chalk in some liquid solution, it will absorb some impurities from the solution on itself, and hence it would act as a adsorbent. So basically, charcoal can absorb all the impurities, and hence these techniques, these face wash and toothbrush and toothpaste contain charcoal. So this is the role of charcoal. Okay, so any other application of alkaline earth metals? So can I give you a question if alkaline and alkali earth metals are clear? Okay, so let's try some questions. Okay, before that I would like to ask, what is deliquescent? Have you heard the term hygroscopic? Hygroscopic. Hygroscopic. Huh? Hygroscopic means anything can absorb water vapors from the surrounding. So you think NaCl, salt, common salt is hygroscopic? Yes, it can absorb na. During rainy days it becomes lumps na. So and hence NaCl is an hygroscopic compound. Similarly, deliquescent is a sort of term for hygroscopic. The only difference is a substance is called deliquescent if it absorbs water molecules to form a solution. Here the compound forms a solution with the water. Deliquescent. What is polarizing power? Polarizing power. All of you have heard about Fazan's rule. What is Fazan's rule? Distortion of anion electron cloud by a cation. Larger the size of the anion, greater is its polarizability. Polarizability. Polar means anything which has separation of charges, plus minus. Polar means plus minus. So if I am saying this is cation, this is anion has an electron cloud, and hence if there is no cation, this electron cloud would be uniform. But if some cation approaches this anion, would this electron cloud will remain uniform? No, right? It will try to distort this electron cloud through electrostatic forces of attraction, and hence if I am saying smaller the cation, larger is its polarizing power. It can polarize the electron cloud, and larger the anion, it can easily get polarized. I would say the anion has a larger polarizability. This is what Fezan's rule is. Right? This is again very important from exam point of view. So, can we start with the p block elements now? Next we have p block elements. Again, why the elements are classified in p block? Because the last electron has been put in the p shell of the shell, right? What are the p block elements? Boron family, 13th group, 14th group, 15th group and 16th group. 17th group is not included in the p block element. This is a different family. This is a halogen family, right? So basically in the p block we have these four groups, 13th, 14th, 15th and 16th. First element is boron, then aluminium, then gallium, then nitrogen, phosphorus, then carbon, silicon, germanium, tin, lead. What is the percentage of lead in the pencil? You all use lead pencils, so it must contain lead, right? Are you sure your lead pencil contains lead? Graphite. But why it is called a lead pencil? You use a lead pencil, right? So it should contain lead. But the actual truth is that the lead pencil does not contain any amount of lead. Sorry. It contains graphite. So why it is called lead pencil? Because initially when the pencil or something pen was discovered, it was called stylus. It was made of lead. Initially लोगों को नहीं पता था पेंसिल कैसे बनती है using graphite. So they made a stylus. Stylus. You have used smartphones, na? They contain a stick, na? This is called stylus. So they made a stylus out of lead. That is why the pencils these days are also called lead pencils, but they contain graphite. So if someone asks what is the percentage of lead in lead pencil, you say 0%. Okay, this is a tricky question, right? Then boron, aluminium, then gallium, indium, thallium, silicon, germanium, tin, lead, arsenic, antimony, bismuth, right? So if I am talking about the 13th group element, again the first element of any group would show a different properties as compared to the rest of the elements, right? What is the electronic configuration for boron? Atomic number is 5, 1s2, 2s2, 2p1, right? So it can easily lose one electron. So it should form ionic compounds, right? Right, na? Boron should form ionic compounds, but this is not true because taking out this electron is very difficult. Again, due to the same reason, because it is very much close to the nucleus, and hence taking out this electron is difficult. So it's better for this electron to share the electron, and hence boron forms covalent compounds. This is very important. Boron forms covalent compound, rather ionic compound. What about aluminium? It has the atomic number of 13. Electronic configuration would be 1s2, 2s2, 2p6, 3s2, 3p1. So it can easily lose 3 electrons. Again, if I am talking about 3 electrons, I am taking out 3 electrons. I have to talk about the ionization energy 1, ionization energy 2, ionization energy 3. Right? So what would be the order of ionization energy 1, 2, 3? 3 would be smaller or greater? Greater? Right? Everybody is getting why ionization 3 is greater than 2 and then 1. Because once the electron is removed, the number of protons are outnumbering the number of electron, and hence the nucleus is getting a larger hold on the electrons so that they do not lose more electrons. Okay, that is why ionization energy 3 is greater than ionization energy 2 than ionization energy 1. It is easy to extract one electron, but once an electron is lost, you cannot easily take out second electron. Nucleus will attract those electrons, and it would make difficult for these electrons to lose, right? And you have to apply more energy, right? This was about ionization energy. The other property could be physical property. Melting point and boiling point, right? Melting point and boiling point should increase or decrease down the group. Melting point and boiling point. It should basically decrease, right? But this is not true. Till aluminium it decreases, but again it increases. Why so? Has everybody heard about inert pair effect? What is inert pair effect? Inert pair effect, if I break the terms, inert pair effect, then that means inert means not participating. So if I am saying that this is the electronic configuration for some element 3s2, 3p1, 3p6. Okay, let it be 3p1. Right? If I am saying that only this electron is participating in the bonding, either covalent or ionic, and this electron is not, these two electrons are not participating, that means these two electrons prefer to be in noble gas configuration, that means they prefer to stay inert, they are not reacting. So this is called inert pair effect, when the electron refuse to participate in the bonding. They would like to prefer inertness. They do not prefer to go into bonding. This is called inert pair effect. The electrons are paired now, and hence they are acting as inert. This is called inert pair effect. And hence down the group, this tendency of inert pair effect increases. So this is aluminium, this should be gallium, indium and thallium. Ideally the oxidation state should be +3 in each of these by losing 3 electrons, but actually in case of thallium, the +1 oxidation state is more stable than the +3 oxidation state, because due to inert pair effect, because the two last electrons would prefer to stay inert. So if somebody asks why +1 oxidation state of thallium is stable than +3 oxidation state, you have to say due to inert pair effect, right? Clear? What could be the other physical property? Electropositivity character we have discussed ionization energy in terms of ionization energy. Density should increase or decrease? Density down the group, increase or decrease? Again there is no defined pattern. Okay, just like melting point and boiling point, there is an anomaly in the trend, right? Similarly, there is no trend in the density also due to inert pair effect. Next physical property is atomic radii. atomic and ionic radii. Make sure these both radii are different. Atomic radii when the electron is intact, and ionic radii when it has lost plus 3 electrons or 2 electrons or 1 electron. So ionic radii should be greater or atomic radii should be greater? Atomic radii should be greater, because when it is in the atom form, the number of protons is equal to the number of electrons. But once it has lost some electron, number of protons will outnumber number of electron, and there would be greater attraction. If there is greater attraction, the size would try to decrease, it would shrink, right? And hence ionic radii would be always smaller than the atomic radii. There would be not much difference, but this is true that ionic radii should be smaller than the atomic radii, right? What should be the trend of atomic and ionic radii? Again, from boron to aluminium, it would increase, but after that it would decrease due to inert pair effect. Remember, this was thallium plus 1. If this is plus 1, it is not preferring plus 3 state. That means it has lost only 1 electron. That means it has lesser number of less attraction to the nucleus. More charge means more attraction to the nucleus, right? Other physical parameter is inert pair effect again. Okay, what is inert pair effect? Inert pair effect means when the complete shell, suppose if I am taking this element 2s2, 2p6, 3s2, 3p6, sorry 3p3 or 3p1, right? If I am taking element having the electronic configuration this, I am saying that that shell, that orbital having the complete field orientation, this s orbital can maximum obtain 2 electrons, and this complete shell, this orbital is already full, and hence I am saying that according to inert pair effect, I am saying it by IPE, according to inert pair effect, the complete filled orbital would prefer to stay inert and does not participate in the bonding is called inert pair effect. That means it refuses that I will not participate in the bonding because I am much more comfortable in this complete form. I would not participate in the bonding. So this is called inert pair effect when the complete orbital refuse to participate in the bonding. So ideally, according to this configuration, you should be saying that the oxidation state should be 3, but actually if it is showing oxidation state of +1. How is it possible that it is showing oxidation state 1? When this 3s2 orbital refuses to participate in the bonding. This is what is called inert pair effect. It prefers to stay inert and does not participate in the bonding, right? Why does inert pair effect occurs? Why does it happen? Why this effect is not applicable to the boron or aluminium or any other element? Any idea? Have you heard about shielding of electrons? What is shielding of electrons? That means protection. That means if I am saying that I am standing in front of you, I am shielding the blackboard from you, right? So similarly, when there is a nucleus, there are electrons around it in the shells. Electrons, there are a number of electrons. They could be s electron, p electron and d electron in any of these orbitals. As I move outside the nucleus, I am saying that these electrons are shielding the nucleus. That means the outer electrons are not being able to see the attraction from the nucleus. If someone is, so it's like nucleus is attracting the electron, but these intervening electrons are not allowing these electron and nucleus to see each other. So this is the these electrons are acting as a shielders. If they do not shield this electron and nucleus properly, then they will feel attraction for each other, and hence it would be difficult for electron to lose the electron, right, for the atom. So this is called shielding effect. If I am saying that S electrons are better shielders, S orbital electrons are better shielders than P, then D, then F, then if I increase the atomic number, that means the number of shells are increasing, that means S, P, D, F electrons are increasing, that means there are increasing number of electrons of the poor shell as well, right? Each time electron is increasing when I increase the number of shell. That means good shielders as well as poor shielders are increasing in number. So as the atomic number increases, the poor shielders are unable to shield the electron from the nucleus, and hence they form greater attraction towards the nucleus, right? Electron feels the attraction towards the nucleus, and hence if the electron feels the attraction to the nucleus, then would the electron prefer to lose? No, na, right? That means electron would prefer to stay in that state only. This is the reason why we observe inert pair effect. When there is a greater attraction of nucleus and electron, then only the loosely bound electron, that means out of 3s2, 3p1, only this complete loosely bound electron is easy to remove, right? This is why we observe inert pair effect, due to shielding of electron. Is it clear? Why boiling point decreases down the group? Why boiling point decreases down the group? Because boiling point. When we melt or boil something, okay, we want the attraction between atoms to decrease, right? So if I am saying that after on increasing the atomic number of shells are increasing, that means number of attraction of nucleus to the electron is decreasing. That means they are now more loosely held to each other. Suppose if I am talking about aluminium or thallium, right? That means they are more loosely bound. As the number of shells are increasing, the attraction of electron to the nucleus decreases, and hence the melting point and boiling point decreases, and hence less amount of energy would be required to break the atoms into their constituent ions, right? Are the shielding and screening effects same? Yes, they are same. Shielding and screening means same. That means am I screening? I am screening the board from you. I am shielding the board from you. Okay. Next properties. So far it is clear that boron forms covalent compounds. Can we talk about the hydrides of boron? With hydrogen it will form hydrides, right? Similarly, aluminium would form AlH3. Similarly, gallium hydride, right? Similarly, there would be reaction with halogens as well. This was reaction with hydrogen. Now we have reaction with halogen. This metal can react with halogen, right? Halogen is represented by X. So this would be MX3, M2X3 or MX3, right? So if I am saying BCl3, this would be AlCl3 and this would be gallium chloride, right? What is the difference between hydrides and halogens? Everybody has studied about boranes. Boranes, what are boranes? You know about alkane? What are alkane? They are the hydrogen compounds of carbon. Similarly, boranes are hydrogen compounds of boron. They are called boranes. So, just like the alkanes have the formula CnH2n plus 2, the boranes have the formula of BnHn plus 4 or BnHn plus 6. N could be 1, 2, 3, 4, any integer. Right? These are called boranes. So basically they are kind of hydrides, right? So if I am taking BH3 or B2H6, I can take. It is complying with the formula BnHn plus 4, where N is equal to 2. So this is an example of borane. What is the... So basically B2H6 is a dimer of BH3, na? BH3 is a dimer of B2H6 is a dimer of BH3. Why it has dimerized? Why would anything would dimerize? To attain stability. That means they are not stable, right? So why do you think it is not stable? What is the electronic configuration for boron? 1s2, 2s2, 2p1. That means like this. 1s2, 2s2, 2p1. This is the ground state, right? If I excite this atom, it would be 1s2 will remain intact. Only the 2s2 electron would go this way. That means maximum how many bonds it can form? 3. That means it can form 3 bonds like this. It would be in the trigonal planar configuration, right? But what about the unsatisfied valency? Other element of this group, say like aluminium, they have, does it have any other orbital? No. Does aluminium have other orbital? Which orbital? S, P, D. Which orbital? They have D orbitals. So hence, if I say that this is forming BH3, then this hydrogen electron cannot combine with any extra shell. While in case of aluminium or gallium or thallium or indium, these hydrides can combine. These hydrides. What are hydrides? Hydrides are H minus. That means they contain 2 electrons. These electrons need space to get fit. So these 2 electrons get fitted into d orbitals of aluminium, gallium, thallium and indium. Right? So if I want to fit these 2 electrons in the hydride, what should I do? I should be able to dimerize it so that these orbitals can double, and hence the hydride electron could be fit in, right? So what is the structure for BH3? It should be trigonal planar, but since we know it dimerizes, its structure should be, does anybody know the structure of diborane? This is called diborane because N is equal to 2, right? It is a banana bond, something like this, BH, H, T means terminal, HT means terminal, which are at the corners, terminal hydrogens, and HB, these are the B, it means bridging hydrogens, right? This is basically a pure ionic bond or covalent bond. Boron always forms covalent compounds. So this is basically a pure covalent bond. A covalent bond is formed when there are 2 electrons and 2 atoms, right? But this is what? This is a sort of banana shape, okay? Here 2 electrons are being shared in the HB by 3 atoms. 3C means 3 center, and hence it appears in the form of banana. This is also called banana bond, in which you have 3 center and 2 electron bond, while this terminal bond is 2 center, 2 electron bond, pure covalent bond. Okay. These were the hydrides for borane. Similar hydride for aluminium would be AlH3, but it would combine with lithium hydride to form lithium aluminium hydride. This is the reagent you have studied in organic chemistry, right? This is used as reducing agent. This hydride is itself does not act as reducing agent, and hence it is preferable to combine it with lithium hydride to form a more stable reducing agent. Banana-like structure. Does boron show catenation? No, boron does not show catenation. For catenation, you need empty p-pi orbitals. That I'll discuss later in the when I start discussing the carbon group. Okay, catenation, everybody knows. What is catenation? When this is the covalent bonding among the same atom, right? Banana-like structure. This is boron, this is hydrogen, this is boron, right? This is like a banana. Banana is like this, na? Right? In general, if you say banana, it's not straight and it's not completely round. And this is the sort of banana shape. Because here 2 electrons are being shared between 3 atoms. Or I am saying 2 electron, 3 center bond. But ये 2 electrons कहाँ से आ रहे हैं? From which atom? Boron, right? Next is a hydride of aluminium. Hydrides we have done with hydrides, right? Next we have alums. What are alums? फिटकरी सबने सुना है? सबके घरों में होती है. क्या होती है फिटकरी? This is what alum is. Alums are basically double salts. What are double salts? You know the formula for more salt. What is the formula for more salt? Is it a double salt or a single salt? Double salt. So how do you define double salt? Okay, just tell me the formula for more salt. Something like ammonium sulfate, then ferrous sulfate, right? Then 2H2O. These water hydration are correct too. Okay, I'm not sure about this too. Okay, this is the more salt. This is called double salt. When the cation and anion are different in the same salt. This is why it is called double salt. These are called water of hydration. Everybody has worked with the copper sulfate in the lab. So what color it has? Blue. But it is not copper sulfate. It is copper sulfate dot 5H2O, because that copper sulfate has absorbed some water from the atmosphere and it has not reacted with the copper sulfate. It has just adjusted itself in the water hydration layer. Okay? If there is a reaction of water with the copper sulfate, this is called hydrolysis. But this water of hydration is just a physical feature. It is imparting some color to the salt, but it is not chemically reacting to the salt. When H2O literally interact or reacts with the salt, it is called hydrolysis. When the H plus and OH minus ions combine with the counter ions, so it would be copper hydroxide and H2SO4. This is called hydrolysis. So basically what is hydrolysis? Reaction of water in which the water breaks down into H plus and OH minus ions and reacts with the counter ions of the salt. So here the water of hydration is not, it is not a chemical reaction. So basically this is also a water of hydration. What you were doing were alums. Alum is Fitkari. What is the formula for potash alum? It is K2SO4, then AlH2O6, then sulfate 2 minus. This is called potash alum. Why potash? Because it contains main ion is potassium. Aluminium salts are basically called alums. So we can say aluminium salts can precipitate out from the solution in the form of alums. Agar if I'm given a salt or solution of aluminium, any aluminium salt, it would try to precipitate out as alum. Okay? So anything, it could be any alum, it could be potash alum or any other metal ion, but this composition would remain same. That means alum would always contain aluminium. That is why it is called alum, A-L-U-M, right? They are basically double salts. So what is the role of Fitkari in your house? Suppose I have given up some water which is very dirty. So if I put Fitkari into it, it will get clean because it will coagulate, right? Coagulate the impurities. Coagulate means उनको एक बंच बना देगा, उनको बिल्कुल इकट्ठा कर देगा सारी. क्या होता है वाटर में? सारी इम्प्योरिटी सस्पेंडेड होती है. सस्पेंडेड मीन्स कहीं भी तैर रही है. बट इफ आई पुट फिटकरी इनटू इट, इट विल coagulate all these impurities into single mass or lump. ठीक है? This is basically coagulation. Already you have studied coagulation in the surface chemistry, right? So this is the role of alum. Alum is also used to stop the bleeding. Have you noticed this role of Fitkari in your house? If somebody is bleeding, if you immediately put the Fitkari on that wound, the bleeding would stop because it will coagulate the blood also, right? Square bracket means coordination compounds. Have you studied the coordination compounds yet? Coordination compounds. So only if and if coordination compounds is clear, you can understand the meaning of square brackets. Basically, what are coordination compounds? In which the metal ion with the ligands, they form a coordinate bond. What is coordinate? Difference between coordinate bond and covalent bond. Everybody knows covalent bond is mutual sharing of electrons, while coordinate bond is complete sharing of pair of electron by only one bond, right? This is the difference between covalent and coordination. So basically square bracket implies coordination compounds, right? Next we have boron, right? Okay, boron can combine with water to form hydroxide. This is the reaction now for the metal ion. Metal ions react with water to form hydroxides only. Remember the sodium dissolved in water to form sodium hydroxide. Similarly, boron would dissolve in water to give boron hydroxide, like this, right? I can write this as H3BO3 as well. This is called orthoboric acid. What is the application of orthoboric acid? It is used as an disinfectant. This is the major application. Disinfectant. Okay. What if I heat this acid? It would form, it will release some water molecule. So if I write minus H2O, I will be left with HBO2. This is called metaboric acid. anything which is called meta, that means unstable. Okay, this is unstable, and hence again it will lose one water molecules to form boron oxide. Okay, B2O3. हो गया 1.5 घंटा? अभी तो टॉपिक भी कंप्लीट नहीं हुआ. Okay. 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 This much is clear till the orthoboric acid. So we can proceed the next topic in the next class. Okay. Thank you. Oh God. मैं तो सोच रही थी